We continue with some state inspection commands, and this time we are going to talk about inspecting the stack. We begin with the program deep.asm. Let's take a look first at the source code. This program contains a data section and a text section. The data section contains this string, which says hello from the depths of code. Next we have the text section. Here we can see that there is a call to some function called func1. If we continue to func1, we can see that this function calls another one, which is called func2. Func2 in turn calls func3, and func3 calls func4. Finally, func4 actually does something. It prints the string that we've seen earlier, hello from the depths of code, to the console. Then it returns, which means that all the functions will return, and finally the program will exit. Take a few seconds to understand the code. Let's save this file, assemble and run it, just to see how it works. We first assemble the file, and next we run the file. We run deep.exe. This is the result we get, the expected string, hello from the depths of code. Let's open this program with WinDBG to find out how to inspect the stack. We resize WinDBG. Next, we open an executable file. We copy the path, and we pick deep.exe. We get deep.exe in a paused state and the debugger command line. We begin by putting a breakpoint on the entry point, and then we use the go command to get to the entry point. Let's add the disassembly window to view more instructions. Next we are going to step until we get to the deepest function, just before we print the string to the console. We are going to use step into. If I use step over instead, I will not be able to get to the deepest state inside the deepest function. I will just be transferred to this instruction after all the internal functions have already executed. Therefore, I am going to use step into. I step into the first function, then into the second one, the third one, and finally the fourth one. Here we have the instructions move and finally call, which is going to print the string into the console. At this point, we can inspect the stack. The simplest way to inspect the stack would be to just use the dd command over ESP. We get all the D words in memory from location ESP and on. This D word is at location ESP. The next one is at location ESP plus 4, and so on. In this memory dump, the first D word is the first return address, the next one is the next return address, and so on. As we didn't build anything complex inside the stack, we can see very clearly the return addresses. In fact, this is the only thing that we have currently inside the stack, at least for the functions that we called. We only have those return addresses. Just to be sure that those are really return addresses, we can do a few things. The first one would be to use the U command to unassemble, for example, at this location. We can see that this location is exactly where the ret instruction is at. If we unassemble at the next location, we will also see a ret instruction. The first ret instruction that we have seen corresponds to this ret instruction, and the next one corresponds to this ret instruction. We could, for example, see this in the disassembly window. Let's again use the ddesp command to view the return addresses. The first address, which is this one, is exactly here. The next one, which ends with 18, is exactly here. And the next one, which ends with 12, is exactly here, as expected. This is about what we can see if we have a very simple stack, or maybe if our functions are really simple. We can just use this command and view all the return addresses. However, we already know that we might get into more complicated situations. As an example, let's take a look at struct_deep.asm. This program is pretty much the same as deep.asm, maybe with one difference. Here, the functions actually build a stack frame and also destroy it on exit. The actual difference is those instructions, enter and leave, which could be seen in any of the functions. We save this program and then we assemble it. If we run this program, we expect exactly the same result. Another difference inside this program is this string, which is a bit different. But basically, this program really does the same thing. It just calls a function which calls another one and so on until the last function just prints a string to the console. If we run this program, we can see that string. Let's open this program with WinDBG. I copy the path, I paste it here, and now I pick struct_deep.exe. Struct_deep.exe is currently paused, and we get the debugger command line. First, let's add a breakpoint at the entry point, and next use the go command. We are paused at the first instruction of the program, we add the disassembly window to view more instructions. Next, we are going to step into the deepest function. We are going to use, of course, step into. Currently, we are inside the deepest function. I want to mention that we did pass the enter instruction, which means that currently we are inside the deepest function between the enter and leave instructions. If we wanted to inspect the stack at this point, we could again use the command dd with the argument esp. And this is what we get this time. Note that this time we have more types of numbers. You can probably guess that those are return addresses. However, we have more numbers. For example, we have this number and also this number. I remind you that those numbers are just the values of EBP when it was pushed to the stack. What the enter instruction does is to push EBP into the stack and then to move the value of ESP into EBP. Basically, it means that this time what we get as an output from this command is a bit more complicated. It might be harder to read in some cases. Luckily, there is a better way to view the stack in these cases, or at least another way to view the stack. There is a special command to do so. It is called k. This command is only going to work well if we have stack frames. If our functions do not build stack frames using, for example, enter and leave, or maybe just using push EBP, move EBP ESP, and so on, the k command will not give a very informative output. Let's see what the k command gives at this example. We can see that we got some kind of a table. Every line is an entry, or maybe one frame, one function frame on the stack. There are a few columns. The first one is called child EBP, and the next one is called return address. Those correspond to the numbers here on this column. Those are the child EBPs, and those are the return addresses. You might be wondering how come we have so many frames. We only had about 4 functions, and here it seems to be like we are having many frames. The answer is that the first frames do not belong to us. As you can see, they are part of NTDLL. Those are some functions that happened just before our program was called as one of the functions. We can see, for example, this strange return address, which is really different from all of those. If we use for a moment the lm command, we can see in the memory map that addresses which begin with 4 are probably our addresses from our module. However, this address, for example, is expected to be somewhere inside the NTDLL module, which is not our code. Just to make sure that we understand the output of the k command, I want to show some other ways of obtaining those numbers. Child EBP is basically just the value of EBP inside the function. We could obtain this value, for example, using the evaluate command, or maybe the question mark command. As we can see, we got exactly this value. If we want to get the return address, we have to do something like this. We have to reference the memory at location EBP plus 4. This really gives us the return address, exactly like specified here. A few more complicated examples, maybe as an exercise for you to understand how it works. How can I get this value and maybe this value? Let me show you how to do it. In order to get the previous EBP, I can use this command. I just reference the D word at location EBP in memory. And this really gives me this value of the second row. Getting this value is a bit more complicated, but we can still do it. This is about how we do it. Basically, POI EBP gives us the previous EBP. And given that we have the previous EBP, we can just use a syntax like this, an expression like this, which is exactly what we see here, except for this part, which represents the old EBP. And indeed we got the correct value. This value equals exactly to this value. Summary of what we have seen in this lesson. We already know that the stack is just a location in memory. Therefore, we should know that we can inspect it using, for example, the dd command, or maybe the question mark command. This is not really a big surprise. The new command that we have seen in this lesson is the k command, which allows us to view the different stack frames. This command is only useful if the functions being inspected actually build stack frames. If your functions are too simple, like in the first example, k will not really help you. It will not give you any useful information, and you will have to inspect the stack manually, using, for example, dd.